All right, question number 14, let's get right into it. So if suppose f is a real value differentiable function defined on the intervals 0, 2, such that f prime of x equals x squared minus x plus 1 on 0, 2, which of the following statements must be true? Okay, sorry, that was kind of fast. So if you look at these answer choices here, we have like f of x and we have concave downward stuff. So I want to figure out what is f of x, what is f prime of x, and what is f double prime of x. So I need to get those, those three things. Okay, so let's see. If I want to get f of x, I'm going to need to take the integral of f prime of x with respect to x. So if I do that really quickly here, let's see, I'm going to get f of x equals, let's see, x cubed divided by 3 minus x squared over 2 plus x plus c, and it is defined on this interval 0. Oh, I don't know, are the edges included in this? Yeah, they should be. All right, so if I set y equal to 0, no, sorry, if I set y equal to 2 and x equal to 0, because they give me those two values, I will have that 2 equals c. So that's going to be my c value. So I'll have f of x equals x cubed divided by 3 minus x squared divided by 2 plus x plus 2. Okay, and they tell me what the f prime of x is just going to be equal to x squared minus x plus 1. And then f double prime of x, well, I'm just going to do this in my head real quick. It should be pretty straightforward. It's going to be 2x minus 1. Okay, so now that we know that, let's go ahead and try answering these questions. So if 0, hang on, let me erase this last thing here. It's kind of in the way. All right, answer is A. If 0 is less than x, which is less than 2, then f of x equals f of 2 minus x. Okay. So yeah, these should not be the same thing, because if I take f of x and I plug in 2 minus x for x, so I have f of 2 minus x, I'm going to get, it's going to be kind of nasty here. Let's see, cube that, 2 minus x squared divided by 2 plus 2 minus x plus 2. All right, sorry, it's kind of running out of room there. But yeah, I mean, if you run this through, it shouldn't give you the same thing. I mean, if I plug in x equals 1 here, let's see. What would that give me? Yeah, it's not going to give me the same thing, because if I plug in x equals 1 here, it's not going to work. Here, let me just show you. So f of 2 minus 1 equals, let's see. So I'll get 1/3 minus 1/2 minus 1 plus, what is this? Plus 4. Okay. So I will get f of 1 equals 1/3 minus 1/2. What is that last one? Plus 3. Okay, but that's not going to be the same thing if I plug in x equals 1 here. So if I use this function here, right, I will get f of 1 equals 1/3 minus 1/2 plus 1 plus 2. Oh, hold up, that is the same thing. Well, I'm like, should I end the video now or should I keep going? Hang on. Let me think here. See, I think it's going to break down if I do like 3/2. Let's see. 4/2, 1/2. No, it almost seems like it works. I mean, I got to be honest with you. It seems like it should work, but I'm pretty sure that if I make x sufficiently close to 0, okay, that's where it breaks down. All right, I'm not going to end the video. You guys can just see me screwing up here. Okay. So let me explain what I was just saying. So basically, if I have f of x, right, and I'm wondering, is this equal to f of 2 minus x? then really all I have to do is just say, all right, well, in the limit, the x approaches 0 for both of these functions, what am I going to get? Well, I'm going to get f of 0, and then I'm going to get f of 2. So clearly these are not the same thing. So no, these cannot be equivalent, okay? So I should have done that at the beginning, but you know, whatever, it's fine. Okay, so there's that, and then let's see here. What would happen if I did the same thing for b? So if I said f of x, and we're not sure if it's equal to negative f of 2 minus x, well, again, in the limit, the x approaches 0, I'm going to get f of 0, and then I'm going to get negative f of 2, and clearly these are not the same thing, so no, it can't be b either. C is interesting, but give me a second here. I will look at that in just a minute. All right, let's do D. So the graph of f is concave upward on 0, 2. Well, if I make x really close to 0, I'm going to get a negative value, so no. It's concave down and up. And then it says the graph of f is concave downward on 0, 2. And yeah, I mean, there's some values for which it is downward, but if I make x close to 1, then I'm going to get concave upward, so no, E is out. So that means that C has to be the right answer, but let's go ahead and see if we can understand why here. So if x is, I mean, if we have this function, right, as the value of x increases, then the value of f is going to increase, right? Because let's see, this is our value here, right? So if x gets bigger, then, I mean, we're going to expect this whole thing to go up. So if I have f of x, or sorry, if I have that x is less than y, then it logically follows that f of x is going to be less than f of y because our function is increasing. So anytime that I increase x on this interval specifically, you know, you should expect it to increase in general. Let me just make sure that that makes sense here. Yep. Yeah, that's the right answer. It's going to be C. All right, guys, if you have any questions, feel free to comment below, and I'll see you in the next video.